Okay, in this video, I am going to go through the three main types of subnetting problems within the IP Subnetting Packet. Here is problem 16 on page 27, 29 in the PDF. And basically, it's asking us that we need 29 usable hosts on our network here. So we want as many networks, subnets, as we can get for this address range 23.0.0.0, and we want 29 usable hosts on each of those subnets. All right, so what we're going to do is, since I don't have a PDF editor software, I'm just going to go type this as problem 16. All right, the class is class A. All right, default mask is 255.0.0.0. Now, so what I'm going to do is I need to find out how many bits I need to borrow to create networks. But first, because I don't know how many networks we want to create, we need to know how many bits I need for hosts. So we need to find the number of bits for a host, right? So basically, we want 32, right? Because power of 2, right? You've got 16 and then 32. 16 is too small, so we need to go to the power of 2 to 32, right? So 2 to the 5th power is 32. So we need 5 bits in order to have at least 29 usable hosts, right? Because we subtract 2 from 32, we get 30. That meets our requirement of at least 29 usable hosts. So we've got 5 bits that we have to have for hosts. This is a class A, so there's 1, 2, 3 octets available, which is 3 times 8 is 24 bits available. So the number of bits borrowed, is going to be 24 minus 5, or 19. Whoop. So we're going to borrow 19 bits, right? So if we borrow 19 bits, all right, our custom mask is now going to be 255, right? We take 8 bits off, and that's 255. We take another 8 bits off, that's 255. All right, so we've taken 16 of the 19, accounted for them, and so that leaves 3, right? So our bits go in high order, so 128, 64, and 32 are the bits we borrowed, so we add those together and we get 224, right? So 224, right? Because our bits go in order 4, 2, 1, and we're taking the 3 bits. Oops. This 128, the 64, and 132, we add them together, right? So that is the 19 bits that we borrowed because we had to leave 5, right? We had 24 bits. We kept 5 at the end, right? And we took 8 plus 8 plus these 3, right? And that comes up with our custom subnet mask. All right, so then if we borrow 19, right, total subnets, right, is going to be 2 to the 19th power. So 2 to the 19th power is 524,288, right? All right. So I copy that and paste it right here, right? So we have 524,288 subnets that we can create, right? Because we borrowed 19 bits. Total hosts are going to be 32. Remember, we took 5, right? We kept 5 out, which 2 to the 5th power is 32. Available hosts, or usable hosts, usable hosts is going to be 30. So now we've borrowed 19 bits. We've created 500,000 subnets. Each subnet has 30 usable hosts on it. Okay. So that's the first style of problem. All right. Then the next one, we'll go to page 34. So page 34. It's the second style of problem here. It starts off like the first one, but then it asks for the ranges of the subnets. So we're going to do this problem 3. It's on page 34 of the packet. So we'll go here. Problem 3. All right. So it's a class C, right? 195, right? So we're at class C. Default mask is 255, 255, 255, 0. Custom mask we can't get right now, but so what we do need is we need 2 subnets, right? So the number of subnets needed is 2. All right. So to do that, our borrowed bits only needs to be 1, right? If we borrow 1 bit, we can have 0 and 1. That's 2 options, capabilities. So if we borrow 1 bit, our custom mask becomes 255, 255, 255.128, because we take that first 128 bit. Total number of subnets is 2. Total hosts is going to be 2 to the 7th, which is 128, right? Because we borrowed 1 of the 8 bits, and that leaves 7, right? So 2 to the 7th is 128, and then usable hosts is going to be 126, because we subtract 2, 1 for the network, 1 for broadcast. And then so now we're going to go answer the ranges question. So what is the second subnet range, right? So our IP address, let's get that, was 195.223.50.0, right? Yeah. And then so then our second range is going to be 195.223.50.128 to 195.223.50.255. The subnet number is just the 195.223.50.128. The broadcast for the first range is 195.223.50.127, right? And the first range is 195.223.50.127. So here's the first range. Here's the second range. This is the network ID. This is the broadcast IDs, right? And because we borrowed the 128 bit, right? This is the number that the networks go up to, if we would have borrowed 2 bits, right? If you borrow 2 bits, then you're borrowing the 128 and the 64 bit, or the subnet mask equals 192, then the networks would go up by 64. And so these would change to 63. This would go to 192, 223, 50. 128, and then because we'd have 4 networks, right? We borrowed 2 bits, we could create 4 networks, and then 64 is let's see here, 2, 8, 7, 1. 72, is that right? I'm having a problem here. 128 plus 64, 192. I was going to say that didn't look right. 192. All right, and then 192 plus 64 would be 256, right? So this would be, the 4 networks would be 195, 50, 191. And then to 195, 50, 223. Got 255, because now we would borrow 2 bits, and since we borrowed the 64, that was the lowest borrowed bit that we borrowed. Our networks go up by that amount, right? 0 to 64, 64 to 128, 128 to 192, right? And then we have 4 networks because we borrowed 2 bits, because 2 to the power 2 is 4, right? So that's how you do your ranges, right? It makes it easier. But the original problem, we only borrowed 1 bit, so the smallest bit was 128. We only created 2 networks. And thus it went up by 128, right? So that's this style of problem. And so then the last style of problem that the book has, we're going to do is page 76. All right, so in here, you're giving a diagram, and you're to design the network addressing scheme that will supply the minimum number of hosts per subnet and allow extra subnets and extra host growth in all areas. And you're to circle on the graphic answer the subnets that you would create. So I'm just going to highlight them, right? So this, well, I can't highlight them. Okay. Let's do, no, I don't want that. All right, so I can't do what I want. So what we'll do is I'll just kind of circle it. So this switch, this connection between the router and switch, that's a network. All right, so that's a network. From this router to this router, that's a network. So we got 2 networks. From this router to this router is another network. So that's 3. Then this router to this router, 4. And then finally you have a 5. 5 networks, okay? So this is problem 9. So problem 9, right? Address class, it's 148, right? So that's a class B. Our custom subnet mask is 255.255.0.0. Now, the minimum number of subnets we need is 5, right? We had 5. And then 5 times 1.5, right? 15%. 5 times 1.15 is 5.75. We round up, so we need 6. So for growth, total number, right? So we need 1 extra, right? So I guess we'll do 1, and then 6 is the total, right? So this is subnets needed. This is growth, right? And then this is total subnets, right? Okay, so we need 6, right? So then we have number of address needed, right? The largest host is Fort Worth with 2,300 hosts needed, right? So hosts needed is 2,300, and then growth is 15%. So 2,300 times 15.15 is 350 or 345. Excuse me, 345, right? And add the 2,300, right? And you got 2,645 total hosts. 2,645. And that's for the largest subnet, right? So now we need to put the subnets in largest group gets the first subnet, the next largest gets the second, and etc. So we've got our IP range of 148.55.0.0, right? And we need 8 subnets, right? So we're going to borrow 3 bits, right? The 128, the 64, and the 32, right? So our numbers are going to go up by 32. 58, 55, 64. Oops, 0. Yeah, 64, right? Dot 0, dot 0. 148, 55, dot 96, dot 0. And we're going to have 8 of them, right? So 3, 4, but we only need 5. So 148, 55, 128, right? So then this is 2, 148, 55, 31, 255, to 148, 55, 63, 255, to 148, 55, 95, 255. Oops. And 148, 55, 127.255 to 148, 55. So 32 is 59.255, right? Because the next one would be 55, 160.0, right? Add 32, right? But we only need 5, right? So so this becomes Fort Worth. This becomes Dallas. this becomes router A to router B, right? This is router A to router C, and this is router C to router D, right? And this is one of your extra ones, right, for growth. But so there's the five subnets, and so that's how you do these problems. So it's fairly simple once you figure out, you know, how many bits you're borrowing and what number you need to be moving up your networks by, right? It's that lower bit number of the bits borrowed for your network number. And then once you do that, then you get the broadcast by just subtracting 1, and it all fills out fairly easy. So that's how I do it, is I always just start with my network numbers, and then it's very easy to figure out what the broadcast is after that. And that is how to do the IP packet problems. Good luck, and wish you well.